I'm standing in front of a brand new building belonging to the German Aerospace Center and the European Space Agency. This is the closest I'll ever come to stepping on the moon. Let's find out what it is and why is it here.
So you're standing in the lunar facility. This is a joint facility between the European Space Agency and the German Aerospace Research Group here in Cologne in Germany. It's a facility that we're using to help prepare for future exploration. We're going to use it for training astronauts in the future. We're going to use it for testing new technologies, developing new operational concepts for lunar exploration, so that when we go to the surface of the moon in the next decades, we're well prepared and well trained for that.
What does it consist of?
The biggest feature of this facility is the regolith hall behind us. So we have this hall where we have about 780 tons of lunar soil material, which we call regolith. So this, we believe, is the largest representation of a lunar surface environment in the world. And we'll be using this for technology development and for training in the future. We've produced approximately 780 tons of regolith material here. We based this material on what we understand of what the moon is made of. We know from the time of Apollo, we know from the samples they brought back what the moon is comprised of. So we're able to find analogues or simulant materials here on Earth that are very close to what you find on the moon. And we've manifested 780 tons of it here. We've laid it out into two kind of areas. We have an area which we call the deep floor area, which is approximately 3 meters deep. And inside that, we have about 1.5 meters of regolith inside it. That allows us to conduct things like drilling operations where we can drill down deep into the regolith, and allows us to create geographical features like craters, for example. The second part of the hall is a relatively flat area. It's about 0.5 meter depth, so not as deep. And this is an area you can do things like just general motivation, locomotion, and basic testing before you go into the cratered area.
What kind of training is conducted here?
So we're based here at the Astronaut Center in Cologne, so we're very interested in the topic of human spaceflight, how we can prepare astronauts for future missions to the space station, but also potentially for future missions to the moon. Here we're going to use the facility to train them on how to actually move around on the lunar surface, how to carry out things like geological sampling, how to carry out different operations, to trial them here, to test them, to perfect them before they go on their real missions. In the future as well, we also hope to have technologies demonstrated here, new rover systems, new technologies for energy systems or excavation. We can test them all here as part of an integrated scenario with the humans and with the robotic systems together.
Can you tell us about the characteristics of the lunar regolith?
So yes, the moon is comprised of this regolith material. This is really fine-grained material that's been formed on the surface of the moon over billions of years of exposure to space environment. Essentially, it's basaltic rock that's been blasted apart over billions of years, and it forms this really fine powder-like material. It's a really interesting material. It's quite aggressive. It's very dusty. It infiltrates everything from mechanisms to seals to equipment. So it's also a hazard. And it's something we have to respect when we go there. We know from the time of the Apollo missions that the regolith is not just an interesting geological feature, but also a challenge for the exploration of the moon.
What challenges does it pose to humans and machines?
It poses a number of challenges to humans and machines. To humans, it poses a challenge in terms of degrading their equipment. So, for example, the spacesuits the astronauts would wear on the surface of the moon, the regolith can infiltrate the surface of it, can infiltrate the mechanisms and the joints. It can degrade the performance of the equipment very quickly over time. It's very abrasive, so it can wear down protective seals and joints very quickly. The same for robotic equipment, things like wheels, things like actuators, robotic arms, even things like lenses. These can be degraded over time by dust sticking to them, and even technical elements like radiators can lose their efficiency over time because dust begins to coat them and reduce their overall ability to reject heat. So it poses a big challenge in many different ways. And this facility here allows us to actually develop new concepts for how we can mitigate against these challenges and demonstrate that they actually are effective before we go to the surface in the future.
Can you tell us about the lab where you are making materials from the lunar regolith simulant?
So one of the things we're looking into is how can you actually sustain yourself on the moon? And one of the ideas is, could you actually build things on the moon using resources that you find locally? So in our team here, we're looking into utilizing the regolith material to see if we could process it in different ways to produce things like building blocks, to see if we can produce things that can be 3D printed, for example, using the materials inside that. And this will be a really important enabler of exploration in the future, because you want to be able to use resources you find locally. You don't want to be dependent upon getting resupply constantly from Earth. And one of the ideas then is to use all these lunar resources around us to sustain missions for longer periods of time, to give us confidence in this capability, so that when we go further into the solar system, we have this capability in our arsenal.
And finally, can you tell us about how you are making composites using this material?
So one of the ideas we looked into is, could you produce composites using regolith? So composites are very common here on Earth. One of the ideas we had is, could we take that terrestrial knowledge and produce something on the moon using composite technology? And we've shown this. We've actually taken regolith sand, we've used it combined with a small amount of polymer filler, so plastic, and by combining it together, you get the ability to make the plastic stick the regolith together and produce things that are very easy to make into different shapes, like bricks or tools and so forth. So composites will be a very interesting way to potentially utilize the resources on the surface of the moon using very little feedstock material brought from Earth.